I guess we can look here. We can look at this arrow. We went from 3 all the way to like 5, or sorry, 8, I guess it's supposed to be. So that's going to be 1, 2, 3, 4, and 5, right? So you have a vertical shift of 5. So from here, what you can tell is that if you add 5, or if you add anything to your output, you're going to have a vertical shift up, basically. Does that make sense up to that point? Did that make sense up to that point?
Yes, it did.
Okay. Cool. So let's go down. So now they're saying if you do instead of a positive, instead of adding, if you subtract, then you would basically have the opposite happen. Instead of moving up, you would move down. So if you add 5, you would move 5 units up. And then if you subtract 3, you would move 3 units down. Now, the reason this is like this is because you're adding 5 to your y, right? So you're basically shifting. So like your f of x is like your y, right? We've been saying. So if you add 5 to your y, you're basically moving in the y-axis up 5. So that's another way to think about that. Okay, so the second thing you can do now is instead of adding to your output or your y value, you can add to your input. And that would be adding to your x. So for example, in this case, if you have the same function, f of x equals 2x minus 1, and you want to add 5 to the input, you would say f of x plus 5 equals 2x plus 5 minus 1. Does that make sense up to that point?
Yes.
Okay, awesome. So now what you can do is you can just expand that out and you get f of x plus 5 equals 2x plus 10 minus 1, right? Which is f of x plus 5 equals 2x plus 9. And so now what they did is graphing our original one, the same one as last time. And now we're going to graph the one where we added 5 to the input. And you'll notice something interesting. So instead of translating up, like what happened when we added it to the output, now we're moving to the left 5. So we're moving to the left. So now, based on this, we can say if we had f of x plus 2, we would translate only 2 to the left, right? But what about if we subtract from the input? Then what we get is basically a movement to the right. So this one is kind of the opposite, right? So in the other one that we looked at, if you add, you go up, you go towards the positive axis, which goes along more what you would expect. And this one, if you add, you move towards the negative axis, so you move to the left. And then if you subtract, you move to the right. So that's your second type of transformation. Do you have any questions on this part? No question? Okay. Okay, so let's take a look now at multiplying by the output and multiplying by the input. So we're still using our same function, f of x equals 2x minus 1. But now what we're going to do is we're going to multiply our whole output by a number. So what they chose was the number 3. So they said f of x equals 2x minus 1, and they want to figure out what 3 f of x would do to our function. So you would take all of the function and multiply it by 3, and you would get, right? So now they're going to graph this one. So they graphed the original, and now they're graphing the new one, the transformed one, and look at where this one is. So it's like a lot different, right? So this line was stretched 3 times as far away from the x-axis. So what we're looking at like what we're using as a reference is that, oh, that's really big. So what we're using as our reference is the x-axis here. And then it moved away from this axis 3 times as much as this one. So that's what happens when you multiply your output by a constant number, you're going to have a stretching effect. So we basically have stretched the graph away from the x-axis. Consider the function f. Yeah, so that's what we did. So let's look at this last paragraph. Notice that the x-intercept stayed in place, but the y-intercept changed. Why would that happen? So do you want to try to tell me why that would happen? So our x-intercept, where we're intersecting with the x-axis, that's constant. But now we're intercepting our y at a different location. I think we're intersecting here now. Oh, I don't know why this shifted. Are you there, Anastasia? Hello? Couldn't hear you.
I'm here.
Oh, okay. So, do you have, like, did this make sense up to this point? Do you have any questions? And do you know, like, why this y-intercept changed and why our x-intercept didn't change?
So are we going across which, are we going across which axis?
Okay, so right now we're not going across any axis. What we did was we're going further away from the x-axis. Do you see how, like, here it's pretty close? And here it's further away from the x-axis. So that's called stretching it away. So we're stretching away from the x-axis. So basically, like,
So you're saying it was a vertical stretch?
yeah, so right. So do you see how this is our new, I don't know if you can see it well on the screen, but this is our new line. So that would be like a vertical stretch, right? Because we're going away from the x-axis. So we're going to, like, we're pulling up the y-axis or by our output.
Yeah, that makes more sense.
That makes sense? Okay, cool. So then you would expect something the opposite, right? A horizontal one stretch to happen if you multiply by the input. So to multiply by the input or to multiply your x value by something, you would get f of 2x equals 4, 2x, right? Oh, it's 2x. 2x minus 1. And so f of 2 times x equals 4x minus 2. So in this case, if you graph both of them side by side, you'll notice that in this case, what is happening is that we're basically moving closer to the y-axis. So in this case, we're stretching across in a horizontal function. We're going closer to our y-axis. Does that make sense? Because in this case, we're altering our input. So I have, they have this summary here that you can basically use whenever you're solving these type of problems. So it kind of tells you like the different change and what it will do. So for example, if you add a constant to f of x and it's positive, then you're going to shift up. That's the first type of transformation that we looked at. And then if it's negative, you're going to move it down. So that's like intuitive. And then if you add it to the input or to x, if it's positive, you're going to move to the left towards the negative side. And then if it's negative, you're going to move to the right. So it's kind of like the opposite. So that's the second type we looked at. And then if you multiply the input, what's going to happen is that you're going to go further away from the x-axis if c is greater than 1. And then if it's in between 0 and 1, then the function goes closer to the x-axis. And then if it's negative, the function reflects across the x-axis. So when you multiply by a negative, that's when you have that reflection that you were asking about. And so if you're multiplying your x by a negative, you're going to reflect across the x-axis. If you're multiplying your whole function, if you multiply your whole function by a negative value, that's when you're going to reflect across the x-axis. And then if you just multiply your x value by a negative, that's when you're going to be reflecting across the y-axis. And I think I have examples on this, so we can look at this better. And then here's the moving closer to the y-axis if your c is greater than 1. And then if it's between 0 and 1, you're going to move further from the y-axis. But any negative will just reflect across the y-axis. Do you have any questions on that? So this is kind of just like a cheat sheet.
Yeah, it makes sense.
Okay, awesome. So I have some problems we can work on. I guess we can start with these, and then I have some more complicated ones on the other one. So let's just look at these. And then I kind of have another summary here, which let me try to select it. Okay, let me move it here so it's closer. So let's take a look at this. So do you want to, based on what we talked about, do you want to work, I guess we can work on number 1 together, and then you can look at number 2 and 3 afterwards. Does that sound good?
We can do that.
Okay. Awesome. So the first one says, so this one, what they're asking you to do is to basically write the translated function. So in this case, they want to move 2 units to the left. And so if you look at what we looked at before, and then at this little like sheet that we have here, if you remember, if you add to your input, you will move that the other, so like if you add, you will move to the left. If you subtract, you will move to the right. Remember, so it's like the opposite. So in this case, what we would be looking at is taking 12x, and then that's where we're going to be adding, or we want to move to the left, right? So that's towards the negative. So yeah, we will be adding. So we're going to say x, and it's 2 units. So plus 2, and then plus 3, and then you can expand that out. 12x plus 24 plus 3. So g of x is equal to 12x plus 27. Is that what you would have gotten to?
Mhm.
Okay, awesome. So that is something you would have gotten. Okay, so do you want to try to do number 2 and then let me know what you get?
Okay.
Um, por eso lo tenía todavía. Y las tapitas de agua. Es un gato, pero yo creo que recogerlas porque cada rato. Sí, sí, cada rato tengo. Gracias.
So
Oh, okay. You have an answer. What did you get?
So I got g of x equals negative 7x minus 39.
Okay. Okay, and do you want to walk me through how you got there?
Okay. So I did what you kind of did in the
Okay.
first problem. I did g of x equals negative 7 parentheses x minus 5 parentheses minus 4, and then I multiplied.
Okay. So you're multiplying by this minus 4? Is that what you did there?
No, that's not what I did. I just added it at the end. After.
Okay, so we don't need the parentheses then, right? Because if we put parentheses, it's going to look like we're multiplying. So we're just going to put it there. That means we're adding. If we put that, then it could be confusing. So let's just leave it like this. So in this case, what you did was you subtracted 5 from your x, right? So if we do that, that gives us a right. That's gonna move us to the right. But then the question wants us to move down. So in this case, if we wanted to do a transformation to the right, 5 units, then we would have done negative 7x then we would have done f of x equals that, and then g of x would equal negative 7x. We're trying to move, we said we wanted to move to the right, right? So then you would have done the negative 5. But minus 4. But in this case, what we're trying to do is we're trying to move 5 units down. So we're not going to be altering our x, or we're going to be actually looking at our output, or y. So what we're going to be doing is basically taking our whole function, and we're going to be looking at this, right? Shifting down k units. In this case, we're taking our whole function and we're just going to subtract those units. So we're going to move up and down the y axis. So we want to move down, so that's why we're going to subtract. So you would basically say f of x minus 5 is what you're looking for. So that's just going to be negative 7x minus 4 minus 5. So that's negative f of x minus 5 equals, you don't need parentheses there, equals negative 7x minus 9. Do you see the difference between what that one would do to our function versus what this will do to our function?
I really don't see the difference.
Okay, so let's look at it on the side here. So in the one that we did earlier, that one we wanted to move 2 units to the left. So we wanted to move horizontally, right? So we wanted to move basically parallel to our x-axis. We wanted to move horizontally, so we're gonna change our x value. But in this case, we want to move up and down. We're gonna move down the y-axis. So in that case, we're not gonna change our x, we're gonna change our y, our output. So instead of adding or subtracting 5 from x, we're gonna subtract 5 from the whole function to move 5 units down. Does that make sense? So if we wanted to move 5 units to the right, then we would have done f of x equals negative. So that's our original function. And then let's say we wanted to move 5 units to the right. So then we're going to take, if we want to move to the right, we're going to subtract. So then we would subtract negative 5. And then in here, we would say x minus 5 minus 4. And then you would just expand that out. What is it, 35 minus 4? Do you see the difference between that and the other thing?
Yeah, now I see it.
Right? So in this case, we're going to get negative 7x plus 31. That's going to be 5 units to the right. But what we want to do is we want to move 5 units down. So instead of adding or subtracting in here, what we're going to do is say f of x minus 5. So we're going to subtract from the whole function. So it would look like negative 7x minus 4 minus 5. So f of x minus 5 equals negative 7x minus 9. And so that's that would be the correct answer for the question that's being asked here. For this question, it would be negative 7x minus 9, since we're moving 5 units down. So yeah, so this one would be shifting to the right. And then if you wanted to shift to the left, you would add 5 instead of subtracting. And then if you wanted to move up your y-axis, or like vertically up, you would add 5 instead of subtracting. Okay, so let's try number 3. What would you do if, maybe you can walk me through what you would do for this one. Here we're going to move 3 units up. Are you there, Anastasia?
Yeah, still trying to solve it.
Okay, you can let me know what you're thinking too. So like we can work on it together if you'd like that as well. So we want to move up. So that's going to be a vertical shift, right?
Yeah. So vertical shift. And we have f of x equals 11x plus 10. Okay.
So if we're looking at a vertical, what type of, what are we going to be changing? Our f of x or our x? Are we going to be making a change to our input, which would be our x, or to our output, which is our whole f of x? What do you think?
I don't even know.
Okay, so let's think about this. So if we're moving up and down, if you have your graph, right? This is your X, this is your Y, and you're moving up and down, that's going to be a change in your Y, right? You're moving up and down the Y axis. Does that part make sense?
Yeah.
Right? So if we're moving, like say, let's pretend these all have the same slope. The only change would be up and down the Y axis. So that means that we're going to be doing a change to our output, our Y, because our functions are in the form of Y equals mx plus b. So if we're moving up and down the Y, we're going to be doing a change to our Y, which is also our f of x. So that means that we're going to be taking f of x and we're going to be shifting it up, right? So we're going to add 3 to it. So that's basically taking 11x plus 10 plus 3. So f of x plus 3 equals 11x plus 13. Does that make sense?
2 plus 3 on both sides.
Yeah, well, I'm just saying, like, we're gonna be so since we're adding 3 to our whole function on one side, we need to do the same on the other side.
Okay.
Right? Does that part make sense? Or is that where it's kind of being confusing?
Yeah, sort of.
It's there? Okay.
Remembering like which one is which.
Yeah, that can be difficult. So that's why I want you to think about it more more is like what is happening actually. So are we moving up the y-axis, down the y-axis, or are we moving left and right from the x to the y? You know what I'm saying? Or sorry, from left to right. So in this case, we're moving up and down, so it'd be a change to what we're changing with respect to the y-axis. So that's going to be our output. That's going to be our whole function. So we're just going to take and add 3 to our whole function to move up 3 units. And if we do that to this side of the equation, then we need to do the same to the other side of the equation. So let's look at it again. So we're going to add 3 to our function, to our output. So f of x originally is f of x 11x plus 10, but we're saying we want to do f of x plus 3. So since we added 3 to this, we need to add 3 to the other side. So you're going to have 11x plus 10 plus 3. So that gives you 11x plus 13. Does that make sense? So the difference is that when we look at a movement, a horizontal movement, we're going to be doing it just to the x, just to the x. But when we're doing a vertical shift, we're going to be affecting the entire function. So instead of having it just be the x, we're just going to do it at the end. So for example, let's look at number 4. So number 4 is asking us to shift 7 units to the right. So because that is a horizontal movement, we're going to be just affecting our x values, right? Because this would be your x axis. So we only are going to change our values in x. So we're going to say f of x. Now we're moving to the right, which means negative, right? So negative 7 equals 8. Now we did this to this side. We are changing our x by negative 7. So we need to do that to this other side of the equation. So we're also going to do x minus 7 instead of x. And then minus 6, that stays the same. And then you would just expand this. Right? Does that make sense up to like here? Because let me know like when I lose you, because I'll just keep going if you don't tell me. And then I won't know if it's making sense or not. Did that make sense or no? Or it's still confusing?
To the right, right?
Yes, correct. We're moving to the right. So you can take a look at this too. So if we're moving to the right, that's going to be horizontal, right?
Yeah.
And then we looked at this earlier. The right is negative. So it's the opposite. When you look at a vertical shift, if you want to move down, you go negative. If you want to move up, you go positive. So that's kind of intuitive, but this is the opposite. To go to the right, you actually have to subtract. And then to go to the left, you actually have to add. So it's a little bit different than what you would expect.
Yeah.
Right? So in this case, what we're looking at is a horizontal shift. So we're in this top box. And then we're looking for right. That means we're only going to change our x by subtracting the units that we want just to our x. And that's what we did here. We said, okay, we want to move 7 units to the right. So we're going to just subtract 7 just from our x. And we're going to do that to one side. So we have to do it to the other side. And that's what we did here.
Mm-hmm.
Does that make sense?
So would we keep it or would we distribute on both sides?
You would distribute. You don't distribute on this side because what they're saying is that the new function is called g of x. So g of x is equal to f of x minus 7. Right? So they could have, like, this is your new function. It has a new name, but it's basically this. So you would only distribute this side just to simplify it and make it look more easy to read. Does that make sense?
Yes.
Yeah. So then you would just say g of x is equal to 8x minus 62. Okay, do you want to try number 5?
So f of x equals negative 5x plus 7.
Mm-hmm.
There's 1 unit left. So we're going to add.
Right. Correct. So what are we going to add to? The whole function or just x?
Just x.
Just
So
x.
it's going to look like f parentheses x plus 1 equals negative 5 parentheses x plus 1 plus 7.
Yeah, that's correct. And then you would just expand that out.
Yeah, so negative 5x minus 5 plus 7. And then we get plus 2.
Yeah, and then you would call that new function g of x. That's correct. So now let's look at number 6.
Wait, will we add or subtract?
For number 6 or for number 5?
6.
For number 6. So remember, here we were doing a horizontal shift, which is the opposite of what you would expect. Here you're moving down, so it's a vertical shift, so it goes with what you would expect, which means down is negative. So you would subtract.
Okay. F of x equals 6x minus 12.
And you're going to move 4 units down. So what I do to my function?
F of x minus 4 on both sides.
Like that. Or would it be like this? What do you think?
Why would we do that? We're not doing the horizontal thing.
Okay, good. So this is right. So you would do this. I was just making sure that you got it. Okay, awesome. So you keep on doing this. So then you would do that to both sides, right?
Yeah, minus 4.
Yep, that's perfect.
You get g of x equals 6x minus 16.
Right, that's correct. So basically from here, we learned that if you're moving up and down, you would do the whole thing, adding or subtracting to the whole function. And if you're moving to the left or to the right, you would just do it to your x value. And then if you want to move to the left, you would add. If you want to move to the right, you would subtract. If you want to move down, you subtract. And if you want to move up, you add. Do you have any questions on these problems? Anyone that you want to look at again?
Can we look at
Sorry, it broke off. Which one? Number 10?
number 1?
Oh, I was like, there's no number 10. Yes, number 1. Let's look at that one again. Let me erase everything. So based on what we discussed, what do you think we should be doing there?
Okay. So left, right?
Mm-hmm.
Okay. F of x equals 12x plus 3. Shifts 2 units left.
So looking at our transformation, what do we have to do? We have to do positive or negative? What do you think?
You have to add.
Okay, we have to add, right? Because we're moving horizontally. Okay, awesome. So we're adding to. Are we adding to f of x or are we adding just to the x? To which one?
Both.
Okay, but are we adding are we doing, so these are your two options. You can either do f of x plus 2 or f of x plus 2. Which one would it be for this case?
The second one.
Right, so you would do this one. So, and we know we're adding 2, so that's good. So then you come back to this guy and you know it's plus 2. So you gonna walk me through it?
X plus 2. And out of the parentheses plus 3. And we distribute 12x plus 24 plus 3.
Which is 27.
Plus 27.
So you get 12x plus 27. Yes, that is correct.
Okay.
So is that more clear now?
Yeah.
Okay, if you give me just a minute, look through this and let me know, look through all of them and let me know if you have any questions and I'll be right back. Need a minute.
Okay.
Okay. Yes. Pero mi mamá me dijo que podía pagarles por Zelle, ¿está bien?
Ajá.
Ok.
El mismo número de teléfono.
¿Sí?
Ajá.
Ah, ok. ¿Y cuánto sería?
Eso fue lo que quedamos con tu mamá. Ella dijo que dependía de ti cómo lo querías por quincena o por mes o como lo
Ok.
quieras.
¿Y cuáles son como tus?
¿Cómo hemos quedado que por quincena? ¿Mm? 60 por quincena. ¿Y por mes?
No sé. Sí.
Por mes.
Sí, porque no sé, de pronto por mes. Es que no sé, solo estaba con un mes, entonces no sé cómo,
¿Cómo te vaya?
cómo qué tanto lo vaya a decir. Sí, pero cuántos, porque también tengo otra amiga que vive acá, que también estaba como pensando, entonces de pronto le puedo decir a ella también si les queda mejor hacer como dos.
Pues sería mejor, ¿verdad? Hacerlo
Sí,
así.
ella tiene 2 cuartos, es un poco más grande el apartamento de ella. Pero le podría decir, pero pues por ahora solo como por, digamos, si solo soy yo, por mes, ¿cuánto sería?
Por mes. Serían como, por un mes serían como de 100 a 115 por mes.
Sí, por mes. Entonces, pues queda mejor por quincena, entonces. Sí, está bien así. Entonces, por quincena, ¿cuánto sería entonces?
¿Cuánto fue lo que te dijo tu mamá?
Pues mi mamá me dijo que es 60, ¿sí? Por quincena está bien. ¿Sí? Ok. Entonces, vamos con Quick Pay Zelle, Send Money. ¿Cuál es tu teléfono también?
281-746-4868.
Ok. Ah, me pide también un email. ¿Tienes un correo con él o no?
No, solamente el número.
No sé. Sí, dice solo.
¿Me tienes agregado como contacto?
No, de pronto es por eso.
Agrégame por eso.
Ah, ok.
Tienes que agregarme.
Ok.
¿Trabajas en la escuela?
No, sino que mi compañía está haciendo como unas tutorías.
Oh.
Entonces estoy en eso. Ok. Está bien así, ¿cierto?
Ahí dice Guadalupe Moreno.
Ok.
Sí, así te tiene que te tiene que salir todos los.
Listo, muchísimas gracias.
Gracias a ti. Entonces, ¿te mando mensaje o nada más llego así?
Pues me puedes mandar un mensaje antes, por si acaso no estoy ahora.
Sí,
Pero...
ya me llegó ya.
Ah, listo. Perfecto. Muchas gracias.
¿El día te importa o puede ser cualquier día?
Puede ser cualquier día, menos como el viernes, porque usualmente no sé qué, si voy a estar acá.
Ok.